Yep, so we want to find the x values which make the function less than or equal to 0. So let's say x is between 1 squared and 2 squared. In this case, the first parenthesis is positive, but the second through the last, the parentheses are all negative. So when you multiply these parentheses, is the sign positive or negative?
Mm,
Yes, this one is positive when x is between 1 squared and 2 squared, but
mm-hmm.
the other parentheses all become negative. So the product of this makes positive or negative.
Negative.
Negative. So
Positive.
yep. So that's the x value we want. We want to find the value which make this function less than or equal to 0.
Mm-hmm.
Yep. And let's try the next interval. So now x is between 2 squared and 3 squared. In such case, the second parenthesis is also positive, but uh, after that, all the parentheses are negative. So what's the sign of the product?
Sign of the product.
Yep, two parentheses are positive and the rest are negative.
Uh, Negative.
Uh, but but there are
Um,
even number of negative parentheses in this case.
uh,
So
so positive.
positive. So this interval we don't want. And how about the next interval? If
Mm,
x is between this, now the three positive and the 97 parentheses are negative, so the sign is positive or negative.
oh, um, Two positive and how many negative?
uh 97 negatives, three positives,
Negative.
negative. So that's another interval we want. So we can say that uh, the intervals are alternating. So we want to find the number of x values in alternating intervals. So that means the number of x value in the first interval is we are subtracting the two endpoints, and when two endpoints are not included, we subtract one again. And in the third interval too, subtract two endpoints and subtract one. So the number of x values in the first interval is 2. So that means 2 and 3 are located between 1 and 4. And number of x values in the third interval is 6. And the fifth interval is the x values, number of x values is will be like this, and that's 10. So it makes the arithmetic sequence. And if we continue this to up to 100 squared, 100, I mean, so there will be 50 intervals. The 50 uh, odd intervals and 50 even intervals. So we can add this arithmetic sequence up to the 50th terms. So we can make the sigma notation. And the difference is 4. And to make the first term 2, we need to subtract 2. And then we can use formula for this. the sum of 1 through 50 is this, and then 2 times 50 is 100, and then because of this equal sign, if any of the parentheses is 0, that satisfies the inequality. So that means uh, uh, 1 through 100 for each integer, each positive integer, it satisfies the inequality. So we are going to add 100 integers. So we can cancel this 100. So uh, 2 times 50 is 100 times 51. So from the choices, options, which one is the answer?
Hmm?
Yeah, yeah. Can you
Oh,
find the option?
yes. E.
Yep. Now 5100 is the answer. Yeah. Let's go to number 18. Yep. There are four numbers. From the set one, one, two, one, one, 0, 1, 2, 3. And if we pick up one of the numbers from the set, we wanna make the a times d minus b times c odd. So if we wanna make the difference odd, one product should be even and the other should be odd. That means, uh, let's say a times d is even and b times c is odd. One of a or d should be even number. So let's say a is even and d is odd, and b and c should be all odd. And now the difference between a, d, and b, c will be odd. And we can move the position of even number. So we can say uh, d is even instead of a, and other numbers are all odd. And if b is even number, all the other numbers should be even. No, b is even. All the other numbers should be odd. Or if c is even number, all the other should be odd. And it's possible that two numbers are even, but in such case, the only one pair should be even, and the other should be odd. That means it's okay uh, for both the A and D even, because even times even is even, but B or C should stay odd. Or if B and C's are even, A and D should be odd. So these are all possible combinations to make the difference odd. So there are total 6 combinations possible. and so 6 times let me see, quadro 4. Okay. So if we think of the probability, the total possible cases is 16 because we are choosing between even and odd, and there are four variables. So 2 to the fourth power is 16, and the possible cases is 6. And then, oh yeah, let's say this way. Yeah, so that's the probability, and the number of total possible cases. Because we are choosing four numbers, and there are four variables, so the total possible cases are 4 to the fourth power. So 4 to the fourth power means 256. So 6 times 16 is 96. So 96 cases are possible. And in number 19, so let's say ant is on the top face, and how many ways possible for ant to go down to the next face?
5.
Yeah, 5. And then the ant can rotate around this. And how many ways are possible for the rotation? Like this, something like this.
Mm. 2.
Okay, so there are 5 faces surrounding this dodecahedron. How can I say? Let me make the name these 5 pentagons: A, B, and C, D, E. The C and D's are in the opposite side, so it cannot be seen, but we know there are 2 faces behind. So that means uh, A to B or A to C, right? A to B, A to C, A to D, or A to E. Uh, that's the that's the clockwise rotation. Or we can, or the ant can also go around the counterclockwise. So if we count the counterclockwise, yeah, counterclockwise. Or it can just make the full circle. Full circle means it starts from A and it ends with A. So there are total 9 cases for the surrounding movement. So 5 times 9 times, and let's say the ant stays at face A, and how many ways the ant go down to the next face? Uh, it can go to this direction or it can go to this direction. for each face. So number of case going down is 2. So we can multiply 2 here. And once again, it can surround the next 5 faces, and the surrounding movement is once again 9. So multiply all these 4 numbers.
Four numbers.
Yep.
Mm.
When you multiply these 4 numbers,
810.
yep. So the answer is E. And let's see number 20. So let's make a diagram for this figure. I'm going to use coordinate. So let's make a B located at the origin. So B is at the origin. And ACD is a right angle, so we can make right angle to locate D.
More cake.
And we can make the diagonal BD, and the intersection point is E. Let's say this angle is theta, let's say this line makes F, and because the triangle ABC and DC are similar, because they are all right angle, and this is a right angle, so that means this angle is also theta. So length of AC is 20, and length of CD is 30. So if we make the coordinates, coordinate of C are 20 cosine of theta and 0, and the coordinates for A are 0 and 20 sine of theta. And the length of AE is 5. And this angle is also theta if we make the parallel line. So coordinates for E are 5 times cosine of theta, and if we subtract 5 sine theta from 20 sine theta, 15 sine theta is the y coordinate. And coordinates for D are we can add the 20 cosine theta and 30 sine theta for x coordinate. And y coordinate is 30 times cosine of theta. Because the BED are collinear, that means the slope for BE is the same as the slope of BD. So in this case, the slope means the y over x coordinates. So slope for BE is 15 sine theta over 5 cosine theta. And slope for D is also y coordinate over x coordinate. And then when you solve this proportion, we can make cross multiplication. and then we can use double angle formula. So 2 times sine theta cosine theta is equal to sine of 2 theta. And for sine squared theta, that's equal to 1 minus cosine 2 theta divided by 2. And for cosine squared, that's half of 1 plus cosine 2 theta. So we can multiply 2 to both sides. So we can simplify this equation. And if we make the square to each side, we get this. And because sine squared and cosine squared is always equal to 1, we can cancel 1. And in this case, cosine 2 theta is not 0. If cosine 2 theta is 0, sine 2 theta should be minus 1. In such case, theta is 3 pi over 2, and so theta is 3 pi over 4, but that's the obtuse angle. But from this diagram, we see that the theta should be acute, not obtuse angle. So because cosine of 2 theta is not 0, we can cancel this cosine 2 theta from each term. And if we divide both sides by cosine 2 theta, tangent 2 theta is equal to 3 over 4, because sine over cosine is tangent. So when tangent of 2 theta is 3 over 4, yeah. And then let's try to find the area of this quadrilateral. So at first, we can find the area of ACD. Yep, so what's the area of this red triangle?
Area of the red
Yep,
triangle.
because this is a right triangle, you can find the area.
Oh, 300.
300. 300 is for the triangle ACD. And then we also want to find the area of ABC.
Oh, that triangle.
And because ABC is also right triangle, we can multiply this 20 cosine theta and 20 sine theta divided by 2. And so for the area of ABC, that's 200 times sine theta times cosine theta. And once again, that's equal to 100 times the sine of 2 theta. And because tangent of 2 theta is 3 over 4, what's the value of sine of 2 theta?
54.
Yeah, from tangent we can find sine value.
Mhm.
So if we make the right triangle, let's say this is 2 theta. What's the length of a hypotenuse?
5.
5. So now, what's the value of sine of 2 theta?
3 over 5.
Yep. So now, what's the area of triangle ABC? If that's 100 times the sine of 2 theta.
So, 3 over 5
Yep.
times
Times
200.
mhm.
600 over 5. So,
Oh,
150.
let's
And
just
now,
see. 100 times 3 over 5. So 300 divided by 5 is, oh yeah, 60. Yeah,
60.
yeah, 60. So now, what's the total area of this quadrilateral? Can you find the option? Yep,
Total left.
yep. Yeah, total area is,
The two triangles.
yep, add the triangle's area.
300 plus.
Yep,
300 plus. What was the other triangle? 360.
yep, 360 is the answer. Internet is a little slow. Let's go to number 21. So in this problem, we want to find the number of terms on the right side. So if we set the variable x for 2 to the 17th power, the 2 to the 289, the power is equal to x to the 17th power. Because 289 is 17 squared. So we can change with the left side. This way. So if we divide x to the 17th power plus 1 by x plus 1, if we use a synthetic division, we can say that this plus minus signs are alternating. So we can make the factoring for each pair. And so all pairs contain x minus 1, so we can make a kind of factoring using x minus 1. And if x is 2 to the 17th power, x minus 1 is 2 to the 17th power minus 1. And we can also simplify the expression. This way. So this means from the first parenthesis, how many terms are in the first parenthesis? If a first parenthesis is equal to this expression, how many terms does it contain?
How many terms does what?
On the right side, I made this wave sign on the right side.
Mm-hmm.
Yeah. How many terms are?
Yes. Oh, give me.
Okay. Can you hear me?
Oh, sorry,
Okay.
my dad was knocking on the door.
Yep.
How many terms?
Yeah.
16? Wait, no, 17?
Yeah, 17 terms. And how many terms in the second parenthesis? If
Second, 16?
there are only
No,
odd
just
number. Yeah.
Only odd numbers.
Yeah, these exponents are all odd.
Mhm. 8.
Great. And then the last one we should include. So this way. So that's the total number of terms. Find this value. Yeah, can you find the option?
Yes,
Yep.
I need to find my calculator.
Mhm.
137.
Yep. So the answer is C. Oh yeah. So 360. Yeah, 137. So, because n is positive integer, we can start from n is 1. So when n is 1, the first this Gaussian uh, value is just 998. So they are all integers. So is the sum of these a multiple of 3? Can you divide this?
Some of
Yep,
these.
yep.
Um,
Is it
ah, um,
divisible by
e-
3?
even odd. No.
This one is divisible
Hold
by
on.
3.
Give me 18. Jesus. 998 is not divisible by 3, right?
But we are talking about the sum. Just add
So,
the sum and then
1,000. Sum is 2997. Yes, it is divisible by
divisible
3.
by 3. So that's not the case we want. We want to find the case, the not divisible by 3. So let's say n is 2. So the first Gaussian number is 499, and second one is also 499, and third one is 500. Oh, yep. In this case, is the sum divisible by 3?
Yes, 998. No,
No, so that's the value we
it is
want.
not.
Yeah, not divisible. So 2 is the case we want, because we want to find the case not
Mm.
divisible by 3. And let's go to n is 3. So first Gaussian number is 332. Second one is 333. Third one is also 333. Yep, is the sum divisible by 3?
Mm, 667. Oh, 998. No, no, it is not.
No, so that's the once again a case we want. Then, and we can say that as the value of n increases, the interval between the first Gaussian number and the third Gaussian number shrinks, right? Because the denominator becomes greater, the fraction itself becomes smaller. So if we make 3 points, each already the distance between the interval is is one or less than, because it shrinks. Uh, the interval is less than one. So what I wanna say is that there may be no integers inside between the interval because the interval is too small, smaller than one. With that in mind, let's see what happens in on the number line. If we make the number line, so let's say there are two integers here, and these 3 points will be located within this one integer, the difference. Let's say this way. So if 3 points are located between two integers, is the sum divisible by 3 or not? In this case, all the
If the
Gaussian,
what?
if 3 points are between this n and n plus 1, all the Gaussian numbers should be n, right? The first Gaussian number is n, second one is n, the third one is also n, because of the property of Gaussian number. So if we make the sum of these 3 points, is the sum divisible by 3 or not?
Mm, yes,
Yes,
if
it's
they are all
divisible by
divisible
3
by 3.
because there are 3 n's, right? So that means that's not the case we don't want.
Mm,
That's not the case we want, right? We wanna find a case not
yes.
divisible by 3. So to be
Wow.
to not to be divisible by 3, one of the points should be located in exactly the next integer. Let me show you the case. So something like this. If one point is located exactly at the next integer, now the sum of these 3 points is not divisible by 3 because the first and second Gaussian number is n, but third Gaussian number is n plus 1. And the sum of these three numbers is 3n plus 1, so not divisible by 3. So that's one case we want. Or or if the second point is located at the next integer, the first Gaussian number is n. For second and third, a Gaussian number is n plus 1. So if we make the sum of these three, that's 3n plus 2, so that's not divisible by 3. So that's another case we want. And, and if the smallest number is located at one integer, now all the Gaussian numbers are 1 n plus 1. So sum of these three is a multiple of 3. So that's not the case we want. So not to be divisible by 3, first or the second number should be located at the integer. So that means n should be uh, a factor of either 999 or 1000. So to find the number of factors, we can use prime factorization. So 999 is the product of 3 cube times 37. So the number of factors is we are adding the 1 to the each exponent. So 4 times 2 is the number of factor, but n is the when n is 1, number 1 is a special case because when n is 1, that's divisible by 3. We should subtract 1 from the number of factors. So the number of factors we want is 7 for 999. And so for 1000, once again, what's the prime factorization of 1000?
Oh,
Yep,
1000?
yep.
Prime factorization. Give me a moment. I need to find a
Yep.
piece of paper.
Okay. Yep. Take your time.
Five cubed times 2 cubed.
Yep. So can you find the number of factors when you add 1 to each exponent and multiply.
When I what?
Add 1 to each exponent and
Oh,
multiply them.
add one to each exponent and
Yep.
then add them.
And then multiply them.
4,
Yep.
4, 16.
Yes, 16. But once again, we are going to subtract 1 because the number 1 is a special case. That's,
So
yep,
15.
so that's 15. So the number of total cases is, yep, can you find the option? 7 and 15 makes,
7 and 15.
yep,
21. Oh,
uh, tw-
22. Sorry, A.
22. Yep, A is the answer.
A.
Yep. Yep. And let's go to number 23. So we want to make some transformations. So there are 5 types of transformations. First 3 is the rotation, and the last 2 are reflection. Uh, hmm. And we are going to use 3 transformations out of these 5, and then we want to find the number of case when the triangle goes back to the original position. And the triangle is located in the first quadrant. So I think we can name on each transformation. So rotation counterclockwise 90 degree. Let's say that's R9, R90. R90. And for the 270 degree rotation, I would say R minus 90. That means that's equal to the 90 degree clockwise rotation. And for the reflection across the x-axis, we can say that's horizontal reflection. And reflection across y-axis, we can say that's vertical reflection. So if we choose one of horizontal or vertical the reflection to go back to the original position, uh, they should go together. So if we make the horizontal reflection, we must also use the vertical reflection to make the original shape. And then we need to use the 180 degree rotation to send back the original shape to the original position. So one option is to choose these two reflections and 180-degree rotation. And the number of arrangement using these three transformation is 3 factorial, which is 6. So there are 6 cases. And if we don't want to use the reflection, we can only use the rotation. And the sum of the degrees should be 0 or 360 degrees to send it back to the original position. That means, okay, if we choose R90 to make it 360, we need to use another R90 and then R180. And now the sum is 360, so it can go back to the original position. And in this case, the number of arrangement is 3 because the R180 rotation of 180, it can be either first position or second position or third position. The other two doesn't matter because they are all R of 90 degrees. And if we choose R of minus 90 degrees to make the degree 0, we should also choose once again our rotation of minus 90 degrees, and then if we choose one rotation of 180 degrees, now the sum is 0 degrees, so the shape goes back to the original position. And once again, the number of arrangement in this case is 3. So what's the total number of cases? Can you find the sum of these 3 numbers from the options?
Yes. 12A.
Yep, there are 12 cases.
Mhm.
Yep. Yeah, 12. So in this problem, the GCD means the greatest common factor. And the property is that uh, if the greatest common factor between A and B is, let's say, the common GCF is M, if we add these two numbers, the GCF doesn't change. So I'm going to use this property. So that means for the first case, GCF between 63, and we can add 63 and m plus 120. That's equal to m plus 183. the GCF between these two numbers is 21. And for the second case, we can also add the n plus 63 and 120, and GCF doesn't change. So now we have the common value, n plus 183. So n plus 183 is also a multiple of 21 and 60. So can you think of LCM of 21 and 60?
E what?
Yeah, least common multiple between 21 and 60. Can you find as least common multiple?
Yes, 2160.
Yeah.
420.
Yeah, 420. So that means this n plus 183 is a multiple of 420. And because we want to find the value of n greater than 1000, we can start with 1260. That's the multiple of 420. So uh, if this value is equal to 1260, uh, in this case, the GCF between 63 and 1260 is just 63, not 21, because 1260 is a multiple of 63. But the condition is that the GCF should be 21, so that's not the case we want. And the next multiple of 420 is 1680. And in this case, the GCF between 1680 and 120, the GCF becomes 120 instead of 60. So once again, that's not the value we want. So what's the next multiple of 420?
420.
Yep. So add 420 to 1680.
420. 1680.
Yeah, plus 420 is
Plus 420. 2000.
yep,
2120.
yep, 2100.
20.
Not 20. I mean,
Oh,
yeah, 2100 exact. And in this case, the GCF between 63 and 2100 is that's 21, and GCF between 2100 and 120 is 60. So now it satisfies both conditions. So this is the value we want. So uh, to find the value of n, subtract 183 from 2100. So what's the difference? Can you find the difference between 2100 and 183?
What is the one?
Find the difference between 2100 and
Yeah, 1917.
1917. And finally, what's the sum of these digits? 1917. So when you add the digits,
Mm,
yep, the sum is
18.
18. Yep, so C is the answer. And let's go to the last problem of this session. So this problem is not easy to explain. Well, let me try. So there are three numbers from dice. Let's say the numbers numbers are A, B, and C, and the domain in this case is 1 through 6. So the first case is if the sum of the two lesser numbers is less than 7, we want to make the sum exactly 7. In such case, we will pick the largest number and roll one die again. To make the sum 7. So let's say, for example, the sum is 6. In such case, if uh, we pick the C, and then let's say the number once again turns up after the re-rolling is D. And if D is 1, now the sum is exactly 7, and he wins. And this type of probability is so uh, getting one number out of one die is 1/6. And this probability is always greater than the probability uh, of getting the number we want by rolling two of the dice. So this means if the two lesser number, sum of the two lesser number is less than 7, uh, he will always pick just one die and re-roll it again. And so if the sum of the two lesser numbers is greater than or equal to 7, now he needs to pick two of the dice, or he just use three of the dice whole again to make the sum of 7. So in this case, we need to compare the probability for rolling two dice and the probability for rolling three dice. So we need to find the probability uh, of getting the sum of 7 by rolling three dice. So let's first find out the probability from three dice. So if we make the sum of A, B, and C equal to 7, so these are possible the triples to make the sum of 7. And the number of arrangement for each case is so number of case to make 7 is 15, and the total possible case is 6 cubed. 6 cubed is 216. So the probability for getting 7 from 3 dice is 5 over 72. So that means the probability to make the sum of 7 by rolling 2 dice should be greater than 5 over 72. So let's think of this case. So let's say the first turn makes this 166. So in this case, we will pick these two, and then redraw these two dice to make the sum of 6, to make the total sum 7. So the probability for getting the sum of 6 out of 2 dice is 5 over 36. And this probability is greater than 5 over 72. So if the first row has these triples, the Jason will redraw 2 dice instead of 3 because the probability from 2 dice is greater than uh, the probability for throwing 3 dice. This one too, he will redraw these 2 dice to make the sum of 6. Sorry, something is not right. Am I right? Yep. I think it takes some time, so let me think it again and let me explain this later. Next week. So let's meet tomorrow for calculus.
Okay.
Yep.
Bye. Have a good day.
Have a good day. Bye.